Did you know that hot water can sometimes freeze faster than cold water? Sounds impossible, right? But it's a real mystery scientists still can't fully explain. Today, we're diving into the fascinating world of the Mpemba Effect, a mind-boggling phenomenon that flips what you thought you knew about freezing on its head. Stick around, because by the end of this video, you'll see why hot water might just beat cold water in the race to become ice. In the 1960s, a Tanzanian student named Erasto Mpemba made a surprising discovery while preparing ice cream at school. He noticed that using hot milk caused it to freeze faster than cold milk. At first, his observation was dismissed as a mistake. However, when scientists later investigated, they confirmed he was correct. This unexpected phenomenon was named the Mpemba Effect in his honor. It refers to the counterintuitive idea that, under certain conditions, hot water can freeze more quickly than cold water. While it may sound scientifically impossible, the Mpemba effect has been observed in various experiments. Researchers believe multiple factors might contribute to this, including evaporation, convection currents, loss of dissolved gases, and differences in how water cools. Though not fully understood, the Mpemba effect fascinates scientists and challenges what we know about heat and freezing. Thanks to Mpemba's curiosity, this surprising phenomenon remains an intriguing scientific mystery that researchers are still exploring today. One possible explanation for why hot water can freeze faster than cold water is evaporation. When water is heated, it begins to steam and evaporate more rapidly than cold water. As this hot water sits, some of it escapes into the air as vapor, reducing the overall volume of water left behind. With less water remaining in the container, there's simply less mass to cool and freeze. This reduction speeds up the freezing process. You can think of it like this. Freezing a full bucket of water takes much longer than freezing a small cup. The same idea applies here. Since evaporation reduces the amount of water, it naturally takes less time to reach freezing temperatures. This effect doesn't always guarantee faster freezing, but it's one of several factors that can give hot water an unexpected advantage in the race to turn to ice. Another contributing factor is convection currents. In hot water, the molecules move much more rapidly due to the higher temperature, causing the liquid to circulate and mix continuously. This internal movement allows heat to be transferred more efficiently throughout the water. As the warmer water at the bottom rises and the cooler water at the top sinks, the heat is distributed and released more evenly, especially at the surface where cooling occurs. This process can help the hot water lose heat more quickly than still, cold water, despite starting at a higher temperature. The constant motion essentially boosts the cooling rate, giving hot water a surprising edge. In contrast, cold water, which lacks this strong circulation, may cool more slowly overall. While convection alone doesn't always cause hot water to freeze first, it plays a key role in how heat escapes and can tip the balance in certain conditions. Then there's the phenomenon called supercooling. Water doesn't always freeze immediately when it reaches 0 degrees Celsius. In some cases, especially if it remains undisturbed, water can cool below its freezing point, but still stay liquid. This is known as supercooling. Cold water is often more likely to experience supercooling, meaning it can remain unfrozen even below 0 degrees. In contrast, hot water tends to avoid this delay and begins freezing as soon as it hits the freezing point. Because of this, hot water might start turning into ice sooner than cold water that's lingering in a supercooled state. This unexpected behavior can give hot water an advantage in the freezing race, surprising us with how quickly it solidifies compared to water that's been cold all along. And we can't forget about dissolved gases. Cold water typically contains more gases like oxygen and carbon dioxide dissolved within it. However, when water is heated, these gases are released and escape into the air. As a result, hot water ends up with fewer gas molecules suspended in it. This reduction in dissolved gases might make it easier for the water molecules to come together and form ice crystals. In other words, with fewer gas bubbles getting in the way, the freezing process can happen more smoothly and quickly. This is another factor that could help explain why hot water sometimes freezes faster than cold water, adding another layer to the complex mystery of the Mpemba effect. Here's the twist. It's not just the temperature of the water that matters. The shape and material of the container can have a big impact on how quickly water freezes. For example, metal containers conduct heat differently than plastic or glass, which can speed up or slow down the freezing process. Where you place the container inside the freezer also plays a role. Some spots may be colder or have better airflow than others. Speaking of airflow, the amount of circulation inside the freezer can affect how quickly heat escapes from the water. Even the purity of the water makes a difference. Impurities and minerals can change how water freezes. Because of all these factors, the Mpemba effect is tricky to reproduce consistently. Sometimes hot water freezes faster, and other times it doesn't. The many variables involved make it difficult for scientists to fully understand or predict when the effect will occur. Some scientists have raised doubts about whether the Mpemba effect is a genuine phenomenon or simply a fluke. In various experiments, results have been inconsistent. Sometimes hot water freezes faster than cold water, while in other cases, it doesn't. This inconsistency has sparked ongoing debate and skepticism within the scientific community. The lack of uniformity in results makes it challenging to accept the Mpemba effect as a universal rule. Researchers have found that no single explanation can fully account for why hot water might freeze faster in every situation. Instead, the effect likely arises from a complex combination of several factors. Where hot water loses volume faster, convection currents, which help distribute heat more efficiently, where water cools below freezing without turning into ice, which can influence how water molecules align to form ice, making it difficult to design experiments that consistently reproduce the effect. Remains a fascinating and unresolved mystery that continues to challenge and inspire scientists studying the behavior of water and freezing processes. So, there you have it. The surprising reasons why hot water can sometimes freeze faster than cold. The Mpemba effect is still a bit of a scientific mystery, but it shows us just how weird and fascinating the world of science can be. If you enjoyed this video, make sure to hit that like button, subscribe for more amazing science facts, and drop a comment below with your thoughts or questions. Thanks for watching, and I'll see you in the next one.